Okay, 4.2, this is the first problem. It gives us this rational function, cubic in both the numerator and denominator, and wants us to give the domain. Now, it doesn't hurt to look at the graph. You can always do that, but we know that the domain is going to be all real numbers except for when the bottom is 0, because that's where it's undefined, or where there's a vertical asymptote, which is also where the bottom is 0. So we can try to find out where the bottom is 0. I'd probably either graph this and see if you can find the vertical asymptote that way. Looking at this, it's a little tricky. It looks like it might be at 4. But like I said, one way is to take the bottom of this and find out where that is 0, so just graph it. And then, yes, it is at 4. So the bottom is 0 at 4, which means that's where this function is undefined, because that's where the bottom is 0. So we would say it's all real numbers except for 4, so negative infinity all the way to 4, as well as 4 to positive infinity. Okay, and then it wants us to give the roots. The roots are where the top is 0. So we're going to now go back to Desmos and just take the top. This is the quickest way. We don't have a way to solve the zeros of a cubic function without using Desmos. And plug the top in, and we see the zeros are at -2 and 7. I guess we could have told those from the original function too, but -2 and 7. And then give the points where this has holes. And it wants them as a comma-separated list of points. Okay, holes are where we have zeros at the bottom and zeros at the top that are the same, or basically where there's a factor in the top and factor in the bottom that cancel. In this case, we know the top has factors x minus 2, or x plus 2, and x minus 7, we know. It has another linear factor of some sort that's we don't know what this is, but that doesn't matter. We know one of the factors in the bottom is x minus 4. We don't know what the other two are, but we know that these aren't the same. If they were the same, then that would be a hole. But basically, we need to look for factors in the top and factors in the bottom that cancel, and those are our holes. So there are no holes in this one, so we can just say none for that. Actually, there is. I didn't graph this very well. There is a hole at -6. So that would be, if you look at the graph, if you turn on, if you graph just the top, it goes through the point. Let me zoom in on that. -6, 0. And so does the other one. If you graph the other one, that one goes through the point -6, 0 as well. So it turns out that -6, 0, it's a factor in both, so x plus 6 must be a factor in both the top and the bottom. Those cancel, and that's considered a hole. So I didn't graph that, I didn't look at it closely enough. But they both do go through the point -6, 0, which means they both have the factor, both the top and the bottom, x plus 6, and that's a hole. Okay, the next question, give the x values where the function has vertical asymptotes. Once again, vertical asymptotes are where the bottom is 0. And we know the bottom is 0, not at the hole, but at the other 0, which would be 4. So I'll just put 4. And then we know the function has a horizontal asymptote at y equals. Now, horizontal asymptotes, when the degree is the same, the top and the bottom is a ratio of the leading coefficients. That'd be y equals 1 in this case. Okay, the next problem gives us another cubic function, so same problem, another practice one. So you can copy and paste this right into Desmos, which is what you want to do. Once you get into Desmos, you want to also graph the numerator and the denominator. So copy and paste those in. Now, the red one right here, so let me turn off the other two and just look at the red one. The red one is the bottom, and we want to know where the bottom is 0, because those are going to be places where our function is undefined. So -9, 3, and 4. So let me write those down. -9, 3, and 4. Now, I want to make sure that the zeros at the bottom are a vertical asymptote, but if any of these zeros are also zeros at the top, then they're factors that cancel, in which case they'd be holes. So now I'm going to look at just the top and find out where those are zeros. I have -9, -6, and 1.3. So the -9 is a hole, because that's a 0 on both the top and the bottom. So keep that in mind. When I give my domain, I'm going to say, it's -infinity all the way to -9, not including -9, as well as -9 to 3, not including 3, as well as 3 to 4, not including 4, and then from 4 to infinity. And then the roots of this function are where the top is 0. So the roots would be -9, comma, get these from decimals, -6 and 1.3, or 4/3. And then it has one hole. That hole is at the point 0 or -9, comma 0. The vertical asymptotes are places where the bottom is 0, so that'd be 3 and 4. So 3 and 4. And then the horizontal asymptote of this function is, horizontal asymptotes are when the degree is the same at the top and the bottom. It's a ratio of leading coefficients, which would be y equals 3 in this case. All that information is on your formula sheet. Okay, another one, similar problem. We have a cubic in the top, cubic in the bottom. We want to answer these similar questions. This time, though, it says the roots of f in increasing order, so be a little bit careful about how we enter those in. Once again, copy and paste this from decimals, so just grab the function, Control-C, go into decimals, and get rid of your other ones, and paste it in. And then I would graph the numerator again, and the denominator separately, so we can answer these questions. All right. So the first question is the roots. The roots are where the top is 0. So we're going to go back to decimals, and we're going to just look at the top. So the top was this right here. We're going to look at where that's 0. You might want to zoom in a little bit, but it looks like we have one at 0, at 1/2, and 3. So we'd say 0, 0.5, and 3. Next, we want the holes. The holes are places where we have zeros in the top and zeros at the bottom that are the same. So places where factors cancel. So we're going to look for the zeros at the bottom now. So go to decimals and just graph the bottom and see where it's the same. So it looks like 3 is the one. 3 was also a hole, or a 0 on the top. So when x is 3, I'm not sure why there's 3 spots here. When x is 3, there's the hole. I'm not sure why there's 3. I guess we'll leave those blank for now. The vertical asymptotes on the formula sheet occur as zeros in the denominator. So we're going to graph just the denominator. And we're going to look for the zeros that aren't holes. So 3 is a hole. 9 is going to be then the vertical asymptote. And also -9. So 9 and -9. And then the horizontal asymptote occurs at, since the exponent's the same, it's a ratio of the leading coefficients, which in this case is y equals -8. The only thing I made a mistake on is this 3 is actually not a root, because when you plug in 3, we know it's a hole. So a hole is not a root, and the reason why is because a hole is a place where when you plug this in, you get 0. A root is where you plug in this 0 and you get a 0. That's not what we get. When we plug in 3, we get 0 divided by 0. So we get 0 over 0, which is undefined. So an undefined value is a hole in this case and not a root. So we don't want to include that. This problem is a little easier than we have a linear function on top and bottom. So the horizontal asymptote, the degree is the same. So it's a ratio of the leading coefficients, which would be y equals 2. The vertical asymptote is where the bottom is 0, which is x equals 1. And nothing cancels, so no factors cancel on the top and the bottom. So we know it's a vertical asymptote. There's no holes for this one. And the y-intercept is where x is 0. So if you plug in 0 for x, you get -1 over -1, which is just +1. And the x-intercept is where y is 0. So plug in 0 for y and solve this equation, which you're solving the top. Because if you multiply both sides by x minus 1 to cancel it, anything times 0 is 0. So you just basically solve where the top is 0, which you add 1 divided by 2, which is 1/2. Okay, another one of these. I know we've done quite a few, but they're really good practice. So we have cubic in the top, cubic in the bottom. The roots are zeros at the top that aren't holes. So once again, we need to graph this and then graph the numerator and denominator separately. I'll do that real quick. Okay, so we're looking at just the top. So I'm going to graph just the top. And looks like the top has zeros at -2 and -4/3. So I'll write those down, -2 and -4/3. And we want to look at the bottom where the zeros are for the bottom too, because we need to figure out where the holes are at. So the bottom has zeros at -4/3 and 8. And okay, so what that means for us then is we know that, like, for example, the top factors into, I'll look at just the x plus 4/3. factor. That's a factor in the top, and we know it's a factor in the bottom as well. That's a factor that cancels. So basically, when you stick in negative 4/3, you get 0 over 0, which is undefined. So therefore, it's not a root, it's a whole. So this is the key point right there. That's a whole. Whenever you have the same 0 on the top and the bottom of this function, because it'll cancel and give you 0 over 0, which is undefined, but it's not a vertical asymptote. So the roots of this equation are negative 2, not 4/3. The wholes are at negative 4/3, the whole. The graph has a vertical asymptote where the bottom is 0, so that'd be at 8. And the graph of the horizontal asymptote is y equals a ratio of leading coefficients, which is negative 1, since the exponents are the same, the top and the bottom. Here's another practice problem. Vertical asymptotes occur at 0 as the bottom. So in this case, we have negative 1/6. If you set this factor equal to 0 and solve, you should get negative 1/6. So that's going to be a vertical asymptote. And then we also have one at set 9x minus 6 equal to 0, the other factor. Add 6 and divide by 9, so that'd be 6 over 9, which is really 2/3. And none of those are zeros at the top, so they're not wholes, they are vertical asymptotes. The horizontal asymptote occurs at, since the exponents are the same at the top and the bottom, a ratio of the leading coefficients. So if you start multiplying the top out, the leading coefficient is going to be 1. Start multiplying the bottom out, and you get negative 54 x squared, so it's going to be 1 over negative 54 for the horizontal asymptote, ratio of the leading coefficients. The x-intercepts are where y is 0, so set this function equal to 0 and solve the top. So it turns out the x-intercepts are at 6 and negative 9. And then the last thing is the y-intercept is where x is 0. So plug in 0 for x, and you get negative 6 times 9 in the top. You get negative 1 times negative 6 in the bottom. That turns into negative 54 over 6, which we can simplify to negative 20, negative 9. Okay, the next problem is a quadratic in the top and a linear in the bottom. Vertical asymptotes occur at 0 at the bottom. I'm going to actually factor this thing completely and really go through this one slowly, just to explain this one well. So I would graph the function. I'm going to graph the top first, though. So here's the top graph. It has zeros at negative 1.5 and 2/3. So that means that I have x plus 1.5, or 1.5 is 3/2. And I have x plus 2/3 as my zeros because, I'm sorry, x minus 2/3. Now, I can actually, you can write that as 2x plus 3 if you want. Instead, that's actually the same thing. You're multiplying this factor through by 2, so it would change the original, it would change the value up here. But that's okay. But here's the factorization, and then in this one, if I could write this as, like, for example, x minus 4 over 9, or x plus 4 over 9. It's actually similar to this. If I divide through by 9, I know that would change the numerical value up front, but there's another way to write this. So basically, you can see that none of these factors cancel, so there's no wholes. What there is a vertical asymptote where the bottom is 0, which is negative 4 over 9. We set the bottom equal to 0. And we can also, give then the horizontal asymptote, which is a ratio of, actually in this case, it's higher in the top than the bottom, so there is no horizontal asymptote. That's on the formula sheet. Okay, so x-intercepts. X-intercepts occur where y is 0, so that's where the top is 0. I can get that from decimals or from right here now, negative 3/2 and 2/3. And then the y-intercept is where x is 0, so plug in 0 for x, you get negative 12 over 4, which is negative 3.